In this tutorial, we are going to create this part. If we look at this part, we can see it is symmetric about the center. So we can make it using Revolve, this profile. You can see this bar license have 29 days to expire. Okay, we create a new part. Let's save this one. You can see there's a star indicating this part is not been saved. After save it, this star is not disappears. We're going to save as. Give the name. I would like to say tutorial 1 and then give my initial. Okay, so we're going to create a sketch and then revolve the sketch. First step, click sketch. We have sketch, drop down menu, either plan sketch or 3D sketch. We're going to create a 2D sketch in this case by select one of this plane, front plane, top plane, right plane. In our case, we're going to use front plane. Let's create some center line as a reference first. So choose this origin, and then when you move up, you can see this vertical symbol is given as a yellow one. And then the yellow symbol shows horizontal, means the line you created is horizontal. So you can see this line and this line lined with this two axes, with horizontal symbol and vertical symbol being displayed. This one indicating coincident point with origin. Once we get this reference line, we will be able to create the shape of the profile. There are several ways to create it. In this case, we're going to create the profile like this. Because there are 3 steps. So you can see here, when I move a cursor, this horizontal dashed line and the vertical dashed line indicating I have the same distance with the end point of the other line. Okay, so I would like to have this one. So when we continue, this line is horizontal, right? Okay, this is the shape. If we revolve this one, we will get a hollow center, and I will get the shape of the disk. All right. Before that, we have a hole here to create. Before we create the whole profile, I would like to define the dimension first. You can see here in horizontal, there are 2 steps. 1, 2, 3 steps. So the total thickness of this disk is 1 inch, and this step is 3.10, and this one is 0.190. So we're going to use this information. Smart dimension, we use this reference, and this vertical line is 1.0. 1.000. Okay, you can see, although I typed 1000, but it only shows 100. So we can change this format. We will do this later. And we also know from here to here is 0.301. From here to here, we know the distance is 0.190. Okay, you can see we only have 2 decimal places being displayed here. Well, what we can do here, go to Option, and here's decimal. There's a decimal place, right? Decimal place. You can see here, only displays the length, only displays 2 decimal. We can change this one to 3 decimal. Hit OK. You can see now the 3 decimal place have been shown in the dimension. Okay, now we're going to put vertical dimension here. You can see here the total, the largest dimension is 0.100 in diameter, so we're going to use 7.1 divided by 2 from the reference line to this line. We also see here's the dimension with the tolerance. So if you already know the basic dimension, then you can use the basic dimension. Okay, you can see here, right? So tolerance plus minus 0.02, unless the other specified tolerances. Okay, so this one actually is 7.100 plus minus 00 plus minus 0.02. Okay, so the upper limit for this one will be 7.12, and the lower limit for this one will be 7.08. Okay, so because we already know this dimension, basic dimension, we're going to use this one. However, we don't know the basic dimension for this one. We can assume something, right? So for this step, because this step, okay, can be considered as a shaft, so we can use lower limit. Okay, so in all the dimension, I'm going to use lower dimension as a basic, lower limit as my basic dimension here. So just in this case, okay, just in this case. All right. We know the dimension from here to here. The diameter is 7.1. So we're going to use 7.1 divided by 2. Okay. So use room to fit to see everything. Okay. And then, you can see we have some problem with here, right? So I'm going to I'm going to draw this one to here, to back to bring it to back. Okay, and also I'm going to make this one longer, so I will be able to use it as my reference. So you can see here we have 3 decimal places showing in the dimension. Okay, so what's the next one? I'm going to use from here to here. The lower limit is 4.7, so 4.7 divided by 2. And we have dimension for this step. This is lower limit 3.52 divided by 2. Okay. And fit. Alright, so now this whole dimension. So we're going to use from here to here. We know this whole is low limit 2.75 3750 and divided by 2 again. Okay, you can see here we only see 3 decimal places, right? So yeah, in this case I'm going to unit decimal places, wrong. Okay, I'm going to change this to 4 decimal places, so I will be able to see the whole dimension here. Alright, we're missing something here because we also have the holes. Okay, we also have the holes. However, this hole can be considered as revolved around the center line. Okay, so we're going to create a center line first. A center line here. By the way, you can see this profile shown as a dark, and all the lines are black. So that means this is an enclosed profile. Okay, enclosed profile. You're ready to use this one to revolve either above this center line or using this line to revolve. Okay, enclosed. And you can see this line is blue. That means this line is not defined. Okay, it's not defined, or say it's not constrained, fully constrained. Okay, we need one more dimension. We know the dimension is 5.9 diameter in diameter divided by 2. Okay, now we can see the hole is, the lower limit of the hole is 0.562. So I'm going to create a line join from here to here. Alright, so the line is 0.526 divided by 2 away from this center line. Okay. Alright, So I'm going to create another profile using this square. Okay, so it can be revolved around this one. So I'm going to create one more. Make sure it's joined in the center. Not center, but the intersection point. Join this one. Oh, automatically related to. Okay. Okay, you can see the line I created. The line created shows it is over constrained a little bit, but that's okay. So this square can be revolved about the center line. Okay, and this color been changed to a different color. That means this square is enclosed. Okay, enclosed. You don't have any gaps around this 1, 2. Let me see. One, 2, 3, 4. Okay, let's see if we can do this. So once you're done, you can see a sketch. Okay, we're in sketch environment. It's been displayed here, and you can see the star showing the modification is not being saved yet. So this is a sketch. Let's see in isometric view. You can use Ctrl+7 to do this as well. We're ready to create the solid. Click feature. So we're going to revolve, including this area, and this area. Those area are section, okay, are sections. So we're going to use the center line to revolve it. Hit OK. Now you can see the overall shape of our plate is being created. Alright, so and you can see the sketch is being hidden automatically. We would like to use it, so show this, okay, show this sketch so we can use it. We're going to revolve cart because we are going to create holes on it. Revolve cart, use the center, and click here, set section control. So this can be selected. Hit OK. Perfect. Okay. Now we can hide the sketch. Only shows the 3D part. However, we know we have 12 holes distributed. So what we can do here, we can use circular pattern, and the direction will be around here, right? So we can choose any of the circular edge indicating the direction. So instant spacing or equal spacing. We use equal spacing here. The equal spacing will be 360 degree, the whole circle, right? So and we would like to have 12. Okay, you may need to change this value. If you only choose 4, what's happening here? Then say select features and faces to pattern, right? So if you have 4, then it's distributed evenly around the circle. Use 4 circles, but we are going to use 12 here. Okay, and hit OK. make sure you're using IPS at the very beginning. Okay, so if you're using the wrong unit, then the actual 3D model will be different. Okay, and actually if you use change now, then and go back to sketch, you can see here the value displayed will be different, right? So you can see here, if you switch back to unit, switch back to, okay, then the unit will be automatically updated. Okay, so this is how we created this part. Now you need to save it, and then you can upload to FOL for your submission. Before that, we would like to use zip folder. This part. Okay, you can use zip folder. Go to right click, folder, and if you check, you can see this part is included.